Hey guys, so today we'll be solving the Leetcode daily challenge problem closest prime number in range. Now in this given question, we are given two positive integer left and right, and we have to find two prime number such that they fall between left and right, and the minimum, it gives a minimum, and if there are multiple pairs, we have to find the smallest number, right? And in the given example, left is equal to 10 and right is equal to 19, right? And the output is 11, 13. Now, if we print all the prime numbers between 10 to 19, we have 11, 13, 17, 19. And the closest pair is 11 and 13 with a difference of 2. Now, let's see how we can approach this. So the first is that we can use sieve of Eratosthenes. Now, after that, we can use binary search to find prime in range. And finally, adjacent prime for minimum difference. And finally, we return the mid pair, right? Now, let's see how we can use sieve of Pareto's theme. The sieve of Pareto theme work on the theory that we will first find all the non-prime number and mark it as false. So let's take 2, right, for the given range. We mark it as false. Move ahead, and then 3, followed by 5, and then we are left with only prime numbers. Let's say that we have found all the prime number between the range. So what now? Now we can use binary search to find first prime which will fall in the given range, right? Now the first prime which will fall in the given range will be, and it is greater than 10, will be 11. So the index of the 11th will be returned, which is 4. And in the C++ implementation, it will be done something like this. Now let's see how we can find the closest prime pair. So once we have determined the range, what we can do is that we can keep on incrementing until a right pointer is less than the range. And we find the differences. So the first difference is 2, 4, 2, and we start storing the minimum difference pair. Now we know that the num1 is the lowest one, and eventually this is the answer with a difference of 2. Now, to summarize the given algorithm, right, what we are going to do over here is that we are going to use a sieve of Eratosthenes to find prime till right. Now we use a binary search to find the first prime, and if fewer than 2 primes are found, then we return -1, -1, right? And the remaining is just finding the difference and keeping track of it and finally returning it out. So that's all about it. Now let's see how we can do the code implementation for this thing, right? So for the code implementation, we can see that in this given code over here, what we can eventually find out that we are using the sieve function over here. Now we actually pre-computed something like this. So the pre-computation ensures that the sieve is eventually runs only once. And the way I'm currently implementing is that I have defined a static variable. The static is sieve computed or not. And this will ensure that it is only written once or run once, right? So if the initial value of this is set to false, right, after that given time, it will be, and if the given value becomes true at some point, let's say after that some point, I'll show you in the given code. So here at the end, you can clearly see that first, if the value becomes true, and we ensure that we are only running it for once. Now after that, the algorithm is pretty straightforward, and we run it, we pre-compute to a upper max limit, like let's say to a limit of 10 lakh, something like that, and given the constraint of the given question. And then what we're going to do is that we're going to maintain a vector S prime, and eventually what we're going to do is that we're going to mark that all the non-prime numbers as false. Now what will happen eventually is that the one which are primes will be pushed inside this integer vector, and that is going to be used for a computation. Now what will happen is that we are going to use a lower bound approach to find the first prime greater than left. Now let's say that we have found the first left. What we're going to do is that we're going to ensure that if the prime number fall between the range, right? And that is very easy because we have found the left, and we know that the given pointer, if it is becoming greater than right, that means that there is no given pair. Now let's say that we initialize our closest pair with -1, -1. Now we iterate through the prime numbers with the left and right? And eventually you can see over here is that we're going to keep iterating until we ensure these conditions are satisfied. That is, we are not reaching the end. And the next thing is that the iterator next value should be less than equal to the right. What is this right basically? This right is nothing but from our closest prime. And this iterator is nothing but we are iterating over primes, prime vector. Now let's see how the difference will look like. The difference is nothing but the difference between the right and the left pointer. And eventually what we are going to do is that at any time we find a minimum difference, what we're going to do is that we are going to update our closest pair, and that's all. And if the minimum difference at any point become 2, because that is the minimum which we can get, we can do something much more smarter, and that is we can break. So just remember that since yeah, that's all about it. But just remember that I have defined these variable as static, so that allow it. Let's say, for example, there are multiple test cases which are running along it. So what this code will ensure that this is the given static functions, and the static functions are eventually run only once, and between the multiple runs, the eventually what we're going to do is that this C is computed will be true, and then that's how we are going to save the time complexity in other problems, like in other test cases. Now if you see, this is a very efficient solution, and eventually you can see that it's the runtime complexity, the runtime is pretty good, and this memory wise, it's also pretty good. So eventually this is something which is in a more readable format, and I will try to upload a GitHub link for this thing. Thank you.